Welcome back to CAD/CAM tutorial. In this tutorial of flow simulation, we will learn different parameters, how to find velocity at the start and at the end of the nozzle, how to find the temperature and pressure at the end and start of the surfaces. So let's start to create this flow simulation tutorial in SolidWorks. Here now we are going to solve a question with the help of SolidWorks flow simulation. The question is, find the characteristics of flowing stream in a nozzle, knowing that a sphere is located in the space between the higher diameter pipe and the reduction zone. Now these estimates, these things we are going to find out. We will see at the mid. Now inlet velocity of different fluids are here: oxygen, water, kerosene. We will take, for this example, we will take oxygen 2.5 velocity, and this is our main nozzle. You will see 10, 10, 10. You will just note down this dimension, and there is a radius, and this is tangent to this face, and there is at the center there is one sphere, 5 diameter. So let's start. Front plane sketch. Now activate center line. Draw one sketch something like this. Okay. Again activate line tool. Now select this line and you will see this option construction, just turn off. Smart dimension 10. Okay. Similarly for this 10 millimeter. Okay. And let's select the center one, 10. Again select this construction line and move cursor downside, and you will see the diameter, that is also 10. For this 5. Okay, what else? Balance. Okay, this is not coincide with origin point. Hold shift key, coincide. Now this is fully defined. Revolve boss base feature. Now axis of revolution, I am going to choose this. Now here in selected contour, choose this one only one, not two. Keep direction blind 360 degree because we want a solid complete. Now thin feature is on. Thickness, it shows 1 millimeter, but let's check. The thickness goes inside, you will see here. So just simply reverse direction. See, thickness goes upside. Okay. Again select sketch, revolve boss base. Axis, this is center one. In selected contour, choose this one. And now see, this time the thickness goes outward direction. So this is perfect. Blind condition, end condition, we choose blind, 360 degree, merge result, say okay. Now let's activate lufted boss base. Now we want to connect these two, so select internal circle. Okay, end condition, let's make tangent to face and make 1 millimeter. Similarly, end constraint, tangent to face 1 millimeter, so that you will get a radius at this point, a perpendicular, this face is perpendicular tangent to this inside face. This is what we want. Now if you come down, you will see one option, thin feature, 1 millimeter. See, we are going to add 1 millimeter upside. Simply choose one direction, 1 millimeter, say yes. Now look, front sketch, activate circle. Now here we want to create one circle, smart dimension, and these diameter 5 millimeter. And center distance, let's say 10 millimeter. And even though we need to define few more things, let's say now this is fully defined. Trim entity, power trim, just press left mouse and drag, and this is trimmed. Okay, revolve boss base. Now here select axis of revolution. So I am going to choose this one. See, if you can't see, okay, section view is not visible. Okay, let's, okay, From this side we can view the visuals. Keep end condition blind because we want a complete circle, so keep 360 degree. Okay. Okay, look. Now it's time to go to flow simulation. Option add-ins. Come down and here you will find option flow simulation. Okay. Now here you will see the flow simulation. Right click and uncheck analysis. Okay. Now before going to create flow simulation, first just close this body from both sides. Okay. So here in tools you will see one option, create lids. If you don't find, simply search here, create lids, and select these two faces, 1, 2. Even though you can choose here thickness, adjust thickness, if you click and adjust the thickness, but we are comfortable with this. This is just for closing the body so that whatever operation is going to happen, it will be performed inside the body. Say okay, now see this is closed. Now go to whole wizard. Please save the simulation. Okay, so before going that, just save it. Let's say nozzle 1, because we already create a, oh let's say nozzle. Okay, we entered in a nozzle 2. Save. Now entered wizard. Here write the name of project, nozzle 2. Next. Now here temperature we like to keep, okay, let's keep Kelvin. Unit SI we will keep as it is. Next. Now here gravity. Gravity is important. See, this is Y direction, so choose gravity. And Z direction shows downward size, we don't need this. 0. And here minus 9.81. Because we want direction, Y direction, downward direction. Next. Now fluid, so we are going to apply oxygen. So oxygen you will find in gases. Oxygen, see here, click add. Now it is add here. Now flow type, if you don't know what is laminar or turbulent, so keep both. Next. These parameters we are going to change, so let's keep as it is. Next. Now see, this is the pressure and this is the temperature. Velocity, finish. Now once you say finish, you will see this box. This is called computational domain. If you don't like, simply hide. Because the operation going to happen with this. Even though if you want to edit, you can change the things, just drag the boundary and it will be, but we don't need it. Okay, subdomain we don't need in this condition. Now, the first thing, boundary. So right click, insert boundary. Now, first we will select, this is the inlet port. Right click on the face, select other, and a small window will pop up. Just move your cursor and you will see the first one is your face or boundary. So select first one, is selected. Type, it is flow opening. The pressure start from here. What we know about this thing, we have dimension, inlet velocity, come down, flow parameter, normal to face, and here we have 2.5 millimeter in according to and click fully developed flow so that we will see. Okay. Again right click on boundary, insert boundary condition. Now this time for outlet. So right click on the face, select other, and here if I move my cursor to this, you will see one face, the window, the things become orange color. Select, not selected. Okay, now it's selected. Now the type is pressure opening. So select this one, pressure opening, and opening is environment. Outside is the environment. These are the pressure and everything. We will change later. Let's keep as it is. Okay, say okay. Now, if you see by default mesh is created, right click edit mesh, show basic mesh. See, if you keep near 7 it will be finer, and near 1 it will be coarser. If you keep finer you will get accurate result and better result, but those result will take more calculation, it will take more time. Say okay. Look, if you don't want this mesh show, just right click on global mesh, hide basic. That's it. Now it's time to run. So simply go to select run. Now run at this computer, new calculation, run. Now see, this is going to run the full operation, and it will take maybe few seconds. If you make mesh finer, it will take more. If you take mesh coarser, it will take little time. So we took finer, that's why it takes time. Now this is solver is finished. Simply cancel. Now if you drop down, and here you will see these all are the graphics. Now we can find out what we need. We can solve all the problems with the help of these graphics. So let's start. If you want to show the flowing of material, oxygen or whatever inside, just let's make transparent this. So in display you will find one option called transparency. Even though if you don't find here, just simply type in search command transparency. You will see, just click on the eye and it will show you where this is located. Now see, this is going to open flow simulation result display, and you will see the red icon. See, okay. Now here transparency, let's keep 95 so that little will be okay. Now look, if you show, it will see, okay, without this is better, hide. Even though again if you want to change more, go to transparency, keep 90. Oh, that's it, because in between there is a sphere and it should be visible. Now here the first question, the average velocity at the outlet. This is a parameter. Now we have to find out parameter. So at outlet, so this smaller one is the outlet portion. So here you will find surface parameter. Right click, insert. Now move your cursor near to this lid, right click, select other. Now you will see first one is your face, selected. Now what you want to find? Velocity, outlet velocity. So here I choose select show. Now here you will see minimum, maximum and average. Average at the center, you will see here one window 10.974 something like this, bulk average. So say okay. Velocity flow field. Okay. Now here we have to generate the graphical field for velocity flow. So before going that, I am going to change this one, outlet velocity. give the name so that it's easy for us to identify. Now go to flow trajectories, right click, insert. Now flow start from opening, so right click, select other, the first, okay, this one face, this orange, select. Now number of arrow you want to show while flowing fluid from inside, so let's say 100. This is the size of, okay, size is going to be, let's say, flow arrow. And here what you want to find, whatever you can choose it, but here we are going to find a velocity field, so select velocity, say OK. Now look, it is generated. Now this is static graphics, right click on flow trajectory, play. Look, the velocity at the end is higher, it's almost 10.974, this is bulk average, and at the end it is smaller, 2.5. Even you can see here at the start 0, and you will notice all the things from here. If you see section view, okay, it's still not visible, but you will see the balls, the arrows move around the ball. Even if you select velocity and find out temperature of fluid, say OK, and see, you will see temperature at the start it's higher, but at the end it's cooler. Look, but normally, even though you can find out pressure also here, say yes. Keep velocity and right click, stop, edit definition. Let's increase the size of this, 3, okay, and even reduce number 80, say OK, that's fine, play. Now it's more visible. Stop. Now here the next problem is pressure distribution within the field. Okay, so just simply right click, hide, cut plot, insert. Now by default it is selected plane front because this is the suitable for us, contour, and we want here pressure, simply choose pressure, and if you make more number of contour, more number of level, it will give the accurate result. So let's say 30, say OK. Look, display uncheck lightning. Now here see, at the inlet pressure is high, at the outlet pressure is low, and at the behind this sphere the pressure is too high. Look, if you change temperature, okay, look, temperature also high at the end, low at the outlet, and behind this temperature is, even though you can find velocity, see, velocity is higher at outlet, low at inlet, and behind this is too low. Even see, after this shadow it is too low. So this is how you can find. Now hide this. Now here the next question is pressure at the surface of a sphere and pressure at the surface of duct. Now go to surface. Before going that, I'll choose section view, front plane. Okay, it will ease us our job to select. Right click on surface plot, insert. Now select this one. Directly choose this ball, contour, and here contour pressure. Okay, let me choose 100 number of contours, so it will give you accurate result. Say okay. Now look, now you will see pressure at the start is higher, mid is lower, at the back side is little mid segment. You will say somewhere like here. Similarly, if you want to again plot, right click, insert. Now select these three from inside. See, contour, and let's say 100 pressure. Okay. Look, if you uncheck section view and look, this is the inside surface pressure and this one. See, at the start pressure is higher, at the end pressure is lower. Look, it's so simple. I hope you like it. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Play. Now you will see. Thanks for watching.